Hello everyone. Hopefully you'll have a pretty good day today. I know there's no Zoom, so I wanted to record this for you so you still get the lesson. Just take a second, review your vocabulary. If you want to pause the video, now would be a good time to do that. Review what you learned last class, and of course we don't have a chat right now, but if you want to just send me a reminder with your answer, that's fine too. Okay, so we're working on solutions today. We're continuing what we started last class. And then instead of joining the quizzes link in the chat, your quizzes, the link should be in your Google Classroom. So look for that quizzes link, go ahead and open that up, either in another tab or on a device, and we'll get started and you'll just answer the questions throughout our lesson. Okay. Remember last class we mentioned that the solubility can be affected by other factors. So whether it's a change in temperature, pressure, what state of the matter the substance is that you're trying to dissolve, all of those can make a change to your solubility. So how likely is it to dissolve? That can change based on these factors and other things. Remember that we have unsaturated, saturated, and supersaturated. If we say something is unsaturated, that means there's just a little bit of solute dissolved in there, so it can still take some more solute. Something that is saturated has that maximum amount of solute dissolved into the solvent. And then something that is supersaturated, that's the case where you have something that's saturated and you've added more and nothing else will dissolve. So it starts to form those crystals or that precipitate. So supersaturated, there's too much solute. Okay, now I'm going to introduce something to you that we haven't talked about yet. These are solubility curves. So what this means is this is just a graph of some kind of abnormal solute or some that you'll encounter often in the lab and how it changes, in this case, based on temperature. So notice that as the temperature increases, and it has it at the bottom in Celsius, a lot of times the solubility of a given substance will increase as well. So you'll be able to dissolve more grams of solute in water as the temperature increases. There are a few of these where they go down, and we'll talk about those in just a second. So if you need to take notes, again, pause the video anytime and take whatever notes you need. Okay, so we talked about how generally the trend is to go upwards as temperature increases. You get more soluble as temperature goes up. That is the case for solids and liquids. Gases are a little bit different. As temperature increases, you can actually dissolve less of the gas solute into the solvent. So gas solubility will decrease as temperature increases. And then as far as reading what those lines mean, that line itself tells you when something is saturated. Anything under the line means it is unsaturated. There's not enough of that solute added. Anything over the line is supersaturated. That's when you'll get that precipitate forming at the bottom. Okay, so question 1. And again, you'll be answering this in quizzes. At approximately what temperature does the solubility of sodium chloride, that NaCl, match the solubility of potassium dichromate? So look at your solubility curves, and you will be using that to answer question 1 in quizzes. All right, by now you should have answered question 1. Let's move on to question 2. So using that same solubility curve picture, which substance is most soluble at 0 degrees Celsius? All right, question 3. Again, we're using our solubility curves. Which solute does not increase in solubility as temperature rises? Okay, hopefully by now you've answered questions 1, 2, and 3. If you have not answered those yet on your quizzes, go ahead and go back in the video and make sure you get those done. Now we're going to talk about something different. We talked about how temperature can affect solubility. We can also affect our solubility using something called agitation. So agitation, it's not when you're frustrated. In chemistry, we're talking about when you're shaking or stirring something. So when you do that, when you agitate your solvent with this, when you're trying to dissolve the solute, it tends to increase that solubility. And that's because every time you're shaking it, fresh solvent that hasn't seen any solute yet will come into contact with that solute so it can be dissolved. So for solids and liquids, more agitation will mean more solute can be dissolved. And again, gases are a little bit funny, but for solids and liquids, more agitation means more dissolving. And then here's some examples of agitation. Notice, if you have your blender bottle where you're trying to shake up your protein powder, it even has that little ball inside that will cause more and more of that, powder to break up and declump so it can be dissolved in the solvent. In the middle, if you're stirring tea or coffee or cocoa, that'll help dissolve. And then on the right, something we use in the chemistry lab. This is a hot plate, but it also, that little table that it's sitting on will shake back and forth and kind of go in a motion where it causes it to be stirred. So these are great if you're stirring something for a long period of time. You don't want to sit there stirring it. You have these plates in chemistry. Okay, so question 4. If we're talking about agitation in chemistry, what is that? Question 5. Stirring the solubility will usually increase or decrease the solubility of something. Okay, and we said that gas was, again, a little bit abnormal. So in this case, when we're talking about agitation, you can think about what happens like with a Coke can. If you drop it or if you shake it, that does not increase the solubility of the gases into the liquid. It actually decreases it. Those gases all of a sudden want to escape, and then that's why you have your drink going everywhere when you try to open that can. So decreased solubility as you have increased agitation when you're dealing with gases. So again, this is with carbonation. Notice all those bubbles forming as you shake it or stir it. That gas is trying to escape the solvent. All right, for question 6, using this solubility curve that's in the picture, which solute is most likely a gas? Okay, question 7. If we increase the temperature or agitate the solution, what tends to happen? And then specifically, we're talking about the more common cases for solids and liquids. Okay, if you need to now, this is your time. If you need to take a 5-minute brain break, I would recommend you do that. We're going to keep talking about some more topics in just a moment. Okay, welcome back. Now we're going to talk about electrolytes. So this is probably something you've heard of. You've heard about how you should drink more electrolytes when you're sick. They say if you're working out a lot, you should have some more electrolytes. You find them in Gatorade, Propel, things like that. These are compounds that are dissolved in water, and they're capable of conducting electricity. So why do you want to conduct electricity? When you have nerves in your body, and your nerves need those ions so that they can carry those electrical impulses. So this is why, like, when you're trying to work out, you need those electrical impulses to work so that your nerves work, so you can move more quickly, so that you can bounce back faster and you don't get tired as quickly and worn out. So this helps your muscles, your nerves, all of those things that help you to function as a human. So what can be an electrolyte? There's a couple of different things. I recommend pausing on this portion of the video to actually write some of this down. You can have strong electrolytes, weak electrolytes, and then non-electrolytes. So strong and weak, think about it, you'll still be able to conduct electricity, but obviously stronger, you can conduct electricity faster. Weaker would be a little bit slower. And then non-electrolytes means you cannot carry a charge. You can't conduct electricity through that. So what makes a strong electrolyte? You have strong acids. I wrote them all out right there. Those are the common ones that you'll want to know about. But notice the little mnemonic I put at the bottom, this CSI-NBC. So if you think of the show CSI on NBC, that will help you. Because then you have like HCl, H2SO4, HI, HNO3, HBr, and then HClO3 and HClO4. So if you want to remember that mnemonic, that would probably be the best way to remember those strong acids. You also have strong bases that form really good electrolytes. This is anything that is row 1 on your periodic table, that far left-hand side, combined with hydroxide, OH. So NaOH, KOH, LiOH, all of those things are strong bases. And then the other strong electrolytes is anything that is a soluble ionic compound. So if you have something like NaCl, where that Na will form a positive charge and that Cl will form a negative charge, when you break them apart, that can conduct electricity. So soluble ionic compounds. And again, you have your solubility table to determine which ones are soluble and which ones are not. And then weak electrolytes, it's basically any of those weak acids, weak bases, and then insoluble ionic compounds, just because not very much of it will break up. For non-electrolytes, these are your covalent compounds. So anytime you have a non-metal pairing with a non-metal, it's not going to want to separate. It will not form a good charge at all. It won't form any charge. So for example, if you have something like glucose or oxygen gas or something like that, it will not dissolve and it will not carry a charge. It is a non-electrolyte. All right, question 8. Which solution, based on those multiple choice options, would be least likely to carry an electric current? Basically, what's that asking is which one would be a non-electrolyte? All right, and question 9. If an electrical current can run through a solution, it is said to contain blank. Question 10, this will be your last one on that quizzes. Weak acids will not fully dissociate in water, so they are considered weak electrolytes. Which of the choices is considered a weak acid? Remember that your weak acids are basically any acids that are not part of your strong acids list that I just gave you. Okay, by now you should have submitted your quizzes. So that was your attendance for today. If you need more practice on this, again, this slideshow that you're looking at right now in the video is available in Google Classroom. And then there's also the quizzes link if you want to try the questions again just for additional practice if it helps you to review. I would recommend take your time, take good notes, pause the video or stay on a slide as long as you need to make sure you understand all the vocabulary. And then if you need to sign up for tutoring, you can always find that on the landing page. I will see you next class when we'll continue learning about our solutions.